Question number 1 here is, during a beta minus decay, a neutron decays into a proton, an electron, and a chargeless particle. What is the name of this chargeless particle? Let me tell you what is a beta decay. So there are three subcategories of beta decay. If I write beta decay, we can write it into three categories. One is beta plus, beta minus, and another one is electron capture. So what are those? In beta plus decay, a proton will be converted into a neutron by accepting the electron surrounding, and in the beta minus decay, a neutron is broken down into a proton and an electron, and the electron capture is simply a process where the electron which are revolving around the nucleus will be captured by the nucleus, and it nucleus will be converted into a neutron. So these are the different categories. But during this process, especially in the beta plus decay and in the beta minus decay, whenever this conversion is happening, along with this, the emitting the proton and electron or accepting the electron, along with that, there is an uncharged, that is the chargeless particle will also be generated. And the question here is for what is the name of that chargeless particle. Let me show you here. Consider this is a beta minus decay which we are talking about. Consider an example of a carbon foot, that's a carbon, so which has like 6 protons and the 8 neutrons. So number of protons and the number of neutrons, so always this is representing the carbon 14 is the atomic mass of the carbon is 14. So usually we represent the element in general as, if I'm talking about the element as X, here the downward it will be written as the atomic number. Atomic number is same as the number of protons, isn't it? Atomic number is same as the number of proton. And atomic mass. So atomic mass is basically the number of proton plus the neutron. So that is atomic mass of this element is 14 and the atomic number here is gonna be 6. Now if this undergoes a beta minus decay, what actually is happening here? Look at here, the number of proton gas increased from 6 to 7 and the number of neutron got reduced from 8 to 7. So there is increment in the number of proton and decrement in the number of neutrons, but there is no change in the atomic mass. Anyway, the atomic mass, what was the before? 6 plus 8, that was 14. Atomic mass will after remains the same, 7 plus 7, it remains the 14. Only the atomic number changes, and this kind of decay it's called the beta minus. And while decaying that beta minus, what are the things are given out? So which are the things are given out here? Along with that, along with increasing the number of proton, an anti-neutrino, that is the chargeless particle which is being emitted along with the emission of the electron. Now question here is about what is the name of the chargeless particle which emits during the beta minus decay? That is, I should say, anti-neutrino. That's the answer. But if I'm telling you, because in the exam they may ask you about the beta plus decay as well, the same thing. When the beta plus decay occurs, as I told, when the proton will be combined with the electron and converted into a neutron. So in that beta plus decay, a proton number will decreases by 1 and the neutron number will increases by 1. Look at here, before there were 6 protons and it is converted into 5 now, and there were 4 neutrons before, it is converted into 5 now. So atomic mass remains same, only the change in the atomic number of that element happens. So that is how it is getting converted. And during this process, instead of emitting the electron, a positron is emitted. Along with that, a chargeless particle which is in the beta plus decay, we called it as neutrino. Neutrino is the chargeless particle which is emitted during the beta plus decay, and antineutrino is the chargeless particle which is emitted into the beta minus decay. So antineutrino and the chargeless particle, whatever we are representing here, the electron in the beta minus decay, it will be also written as beta minus, or sometime it will also written as electron with its nucleus nuclear number is 0 and its charge is going to be -1. So they may use this notation for electron they may use this notation. It doesn't mean, so it means the, like, you know, it is, they are representing the electron. So we're gonna say answer to this question, it's gonna be anti-neutrino. This is the chargeless particle which is emitted. Question number 2 here is, the figure below shows a light ray that travels from a material 1 and arrives at the interference between material 1 and material 2. What is the angle of reflection? So the diagram has been shown here. Question is about what is the angle of reflection. Basically, whenever a light ray enters from the material 1 to material 2, or whenever the light ray strikes on the boundary of the different medium, the part of the light will be reflected back and the part of the light will be refracted. So if I am representing a ray diagram for this, the part of the light will be reflected. As I say, suppose the light ray is hitting this boundary of the material 1. So material 1 may be any, maybe air or water, anything, it will be mentioned to you. And this is the material 2. So when it is hitting the boundary of the material 1 and 2, the point where it hit, it is said to be the normal. This is whatever the y-axis which has been represented here, it is called the normal. Now what is the angle of reflection? As I said, when the light ray hits to the boundary, there is two things happens here. The part of the light will be reflected, it goes back like this. This is called the reflection. This is called the reflection. And the part of the light will be refracted, enters into the medium. This is called refraction. So reflection is different and the refraction is different. Now question is about what is the angle of reflection. So how do I calculate the angle of reflection? So whenever the light ray goes back, bounces back by hitting this certain medium's boundary, the angle of reflection is same as the angle of incident. Now you may ask you, what is angle of incident? This is not the angle of incidence. This is not the angle of incident. So angle of incidence is the angle made between the angle between the normal and the incident ray. This angle is called the angle of incidence. So this is usually we represented as theta I. So theta I, it's basically, I can say, angle of incident ray, incident. And what is the angle of reflection? Angle of reflection is this, the angle made with the normal and the reflected light. So that usually we represent as theta r. This is the angle of reflection. And how the angle of incident and the angle of reflections are related. Whenever a light ray hits to the boundary and bounces back, one thing remember, angle of incident is same as the angle of reflection. These two angle will remain the same. Angle of refraction will be different, but incident angle and the reflected angle will be same. So how do I calculate that incident angle now? So as we know, the y is representing the normal, whatever the line which you have drawn, this is representing the normal to the plane, normal to the plane, or normal to the boundary which we are drawn. And whenever we are saying the normal, it makes an angle of 90 degree with the surface plane. This angle is going to be 90 degree now. In this angle, if we say 90 degree, then one of the angle with the incident light and the plane has given to us as 60, then how do I write it? This arrangement can be written as now incident angle plus 60 degree, both add up to give you 90 degree. So from this one, I can calculate what is the angle of incident just simply by arranging this. So angle of incident here is going to be written as 90 minus 60 degree. That is, angle of incident is 30 degree. And I told angle of incident is same as the angle of reflection. So from this one, I can conclude that angle of reflection is also equal to 30 degree. This is the angle of reflection here, and which is the answer choice which has given to us. A is the right answer because the angle of reflection we got it as 30 degree. Question number 3 here is, three capacitors are connected in series as shown in the following diagram. What is the net capacitance between the points X and Y? So what is the net capacitance of this arrangement? That's the question. So if you can see here, the capacitors are connected in series. As they have already mentioned, this type of arrangement is called series. And while finding the net capacitance of the capacitor when they are connected in series, we need to follow the net capacitance. Assume that, let me give that name as for my reference, it will be written as capacitor 1, capacitor 2, and capacitor 3. Whenever the capacitors are connected in series, the net capacitor we calculate by using this rule. So 1 by Cs is the total capacitance in series is equals to 1 by C1 plus 1 by C2 plus 1 by C3. This is the formula when the capacitors are connected in series. So what will be this? You just need to substitute their values. So 1 by Cs, whatever the value you are getting, 1 divided by what is the value of first capacitor? It's going to be 24 microfarad plus 1 by 39 microfarad plus 1 by what it is, 43 microfarad. So if you insert the values as it is in the calculator, you'll be getting 1 by Cs is equals to 0.09056. So this is the value what you are getting, but actually the question is about what is the value of net capacitance, the total capacitance in series. So to get the value of Cs, you have to reciprocate it, flip it. It means this can be written here as Cs will be calculated as 1 by this value, so 0.09056. If you substitute, if you reciprocate it, you just need to press a inverse button on your calculator, inverse answer, it will give you the value. So that will be written as 11.04 microfarad. No need to write the unit like micro every time, 10 to the power negative 6, 10 to the power negative 6, because all the capacitance will be having the same. So this is equivalent to 11.04 microfarad, and then our answer matches with the option A. So this is how you calculate the whenever the capacitors are connected in series. There is another calculation. This is not related with the question, but let me tell you. How do we calculate when the capacitors are connected in parallel? Which type of arrangement say parallel? This is the series. This is the series arrangement. And how will be the parallel arrangement of the capacitor? Parallel arrangement is, so when the all the terminals of the capacitors are connected at the one point, I can say this is the one point of the capacitor, this is the another terminal of the capacitor, this will be connected, this is the one capacitor, this is this arrangement. This type of arrangement, it's called a series, parallel connection. Arranging the capacitor in the parallel. This is can be said to be point X, point Y. They may ask you what is the net capacitance in this arrangement. So if I'm saying C1, C2, C3, so the net capacitance Cp when it has been connected in parallel is simply adding them as it is. C1 plus C2 plus C3. So the net capacitance here is going to be adding them all. That is the value of the net capacitance which is connected in parallel. That's, they may ask you also a series or the parallel. This is what you need to solve, right? Question number 4 here is, the illustration shows a steel rod is fixed between the two walls. The rod has a length of 10 meter and a circular cross section area with radius 0.03 meter. How much force is generated by the rod on the wall if the temperature increases from 20 degrees Celsius to 40 degrees Celsius? So this is the arrangement. So the rod has been fixed between the two wall, and original length, the initial length of the rod, it's gonna be 10 meter. So initial length, sometime we represent as the L naught. Let's assume that L initial length is gonna be the 10 meter. And as the temperature increases, what happens? The rod will get expanded. That is what the linear expansion. So rod will get expanded with the certain factor. And when the expanding that rod, so definitely it will be touching to the wall, and it is insert, in like this is touching to the wall, and it is pushing that wall towards. So it's applying the certain amount of force. Now question is about what is that force? We have to calculate what is the force exerted by the rod when it get expansion. And the cross sectional area of that rod also they have given to us. It's a circular rod. So now what we need to calculate is what is the force exerted by the rod. So to calculate this, we need to go with the one expression calls what we say the modulus of elasticity. So there is a formula to calculate that, what we say modulus of elasticity. So what is the elasticity? That is basically the tensile stress or the tensile strain exerted by the rod on the surrounding material. And this formula usually we write it as modulus of elasticity. Generally we represent with E. This is equals to, this elasticity formula will be equal to F times the L naught. F is the force exerted times the original length of that rod, F times L naught, divided by A times delta L. So what is this delta L is representing? Delta L is representing the change in the length because of the increase in the temperature. Let me read each of the what are this one. As we say, E is the modulus of elasticity. Modulus of elasticity can also be said as Young's modulus. This is the another name. Young's modulus is same as the modulus of elasticity. So what is the F is representing here? F is representing the force. L naught is representing the initial length. L naught is representing the initial length. A is representing the area, basically the cross-sectional area of that rod. Area of cross section, area of cross section. And what is this delta L is representing? Delta L is representing change in the length, change in length. So these are the things what I need to know about. So in this one, so to calculate the force, I have to arrange this given expression in terms of F. You have to arrange this force formula in terms of F. So how do you can arrange it? So by doing the simple mathematics, what I can do is that I can arrange the value of F. I can write the value of F as E times A delta L divided by L naught. So this is what I can arrange. Now I have to calculate the force. Now to calculate the force, I should know the how much is the increase or change in the length, and what is the area, what is the initial value I know, and what is the Young's modulus. In general, for the at the room temperature, that is 25 degrees Celsius, the value of the Young's modulus ranges from 1.9 into 10 to the power of 11 to 2.1 into 10 to the power 11. So Pascal. So 1.9 into 10 to the power 11 to 2.1 into 10 to the power 11. But this is, we here we don't know the exact value, but in the exam, exact value of this modulus elasticity will be given to you. By making use that, you can calculate. As we know, in your physics exam, the reference sheet, the formula sheet will be provided to you, and all the constants values, all the required information related to the questions are included in that. You can make use accordingly and you can solve it. So I know the value of E now. I can calculate what is the value of A, that is the area. Area, it's, if I'm representing that cross section, it is simply looks like a circle. If I say the front side of it, so it looks like a circle with a certain radius as 0.03, right? So, and what is the area of a circle? Area of a circle is pi r square. Substitute the value of this. This will be written as, let me write it here, pi times 0.03 square. So I know the area now. I know the initial length, which has been given to us as the 10 meter. Now let's calculate the change in the length. That is the linear expansion. There is another formula to calculate the change in the length. So delta L will be written as alpha times L naught times the delta T. The change in the length, it's basically alpha, that is the linear expansion constant. This will be written as linear coefficient coefficient of expansion, linear coefficient of expansion, and on an average the value of alpha is going to be 1.2 into 10 to the power negative 5 per degree Celsius. Per degree Celsius is its value. I know the initial length. Now what is the change in the temperature? Delta T, change in the temperature. If you see the initial temperature we had like 20 degrees Celsius, I can say T1 is 20, and the final temperature T2 is gonna be 40 degrees Celsius. I'm just using this as to calculate the change in the temperature. Change in the temperature is T2 minus T1, that is 40 minus 20, that gives you 20 degrees Celsius. Substitute all these values in the above formula. You'll be knowing the value of what is the delta L. So delta L, change in the linear expansion, can be written as 1.2 into 10 to the power negative 5 times what is the initial length L naught, is gonna be 10, times change in the temperature is 20. If you substitute these all values in the calculator, you'll be getting it as 2.4 into 10 to the power minus 3 meter. So this is the change in the length. So now by making use this, we can calculate what is the value of the force exerted. So we know F is equals to, we have the formula EA. So EA delta L divided by L naught. Substitute their values. Elasticity modulus, I'll be taking it as, let's go with extreme, 2.1 into 10 to the power 11. Area is gonna be just, I can write as pi times 0.03 square times the original, like change in the length, the delta L, we got it as 2.4 into 10 to the power minus 3. This entire thing, this whole result divided by L naught. What is the initial length we had? 10 meter. After inserting these values as it is in the calculator, you'll be getting the answer. That value here you'll be getting it as 1.420 into 10 to the power 5 Newton. This is the amount of force which is exerted. So 1.42 into 10 to the power 5 Newton. But if you look into the option, so this is what I am getting here. But if you look into the option, so none of the option giving me this value 1.42. But as I told, I don't know the exact value of the Young's modulus constant, but in exam it will be given to you. I have just taken the range value, the extreme value. Based on that, I'm calculating. So my answer, force which is exerted, is getting slight 0.08 Newton more than as compared to that. So the nearest value which is matches with that 1 point. So nearest value 1.42 into 10 to the power 5, which is matches nearly with the 1.34. So this is the answer which I can go with. So why there is a difference? Because I don't know exact value of that E, but in exam it will be given to you. So you can substitute as it is, and I'm 100% sure you're gonna get the same answer what they have mentioned here, right? So that we go with option A as the right choice here. Question number 5 here is, a 20 into 10 to the power negative 6 coulomb charge is moving at a constant speed 5 into 10 to the power 7 meter per second through a magnetic field strength of 3 Tesla at an angle of 30 degree with the magnetic field direction. Find the magnetic force on this moving charge. Now question is about the arrangement has been shown to us. A charge is moving, value of charge is given to us, and the charge is moving in a magnetic field which has been represented in the direction B with the speed. A charge is moving like this means a charge is moving. Suppose if the same charge here I represent with the magnetic field, a charge will be moving with this direction and it is making an angle of 30 degree with the magnetic field, and the speed of the charge they have given to us. Speed means the velocity of the charge is given to us, and they are asking us what is the magnetic force exerted on that charge because of the magnetic field. This is a simple and the straightforward question which based on the formula, there is nothing conversion and all are required. The formula for the magnetic force FB will be written as QVB sine theta. This will be the formula. FB is equals to Q V B sine theta. So what is the FB is representing the force, where FB is representing the magnetic force here, magnetic force. Q is the charge, Q is the charge, V is the speed or velocity, also we can say speed or velocity, and the B is the magnetic field, magnetic field. So all the values are given to us. So all the values, what is the value of charge? Q value they have given to here us. If you substitute here, if you substitute, let me write it here. FB is equals to QVB sine theta. If you substitute the value of charge here is what? 20 into 10 to the power negative 6. This is basically representing the value of charge. And this is representing the speed. This is the V. And this is representing the magnetic field B. And this is the angle. So substitute here 20 into 10 to the power negative 6 is the value of charge. 20 into 10 to the power negative 6 coulomb times what is the speed, which is moving, 5 into 10 to the power 7. 5 into 10 to the power 7 meter per second. And what is the value of B, that is the magnetic field? It's going to be 3. And sine of angle 30, the sine of angle 30. If you insert these values as it is in your calculator, you'll be getting the answer to the sine of angle 30 we are getting, right? Yes. If you insert this value as it is in the calculator, you'll be getting that as 1500 will be the value. So 1500 Newton, because unit of that force is going to be Newton. So this is the answer to the question what they are asking us. So I should go here with the option A. Just substitute their values and check it out. You'll be getting this value as the answer. So A is equals like force exerted on the charge is going to be 1500 Newton, and that is option A. Question number 6 here is, a ball is thrown vertically up in the air and then caught again. Which velocity time graph for the ball is correct? The question is about representing the velocity time graph of the ball which is thrown vertically upward and caught again. So let's take, for example, if I just draw a velocity time graph of the situation what they're talking about. Let's take x-axis, let's take it as a time, and the y-axis as the velocity. So before drawing, let me tell you, assume that this is the ball, and if I'm throwing it vertically upward, it goes, reach to certain height and falls down. So let me tell you, when the ball is thrown vertically upward at the point of throwing up, initially it has the greatest velocity, because as the ball is going upward, velocity is decreasing, reaches to the highest point, it means the velocity becomes 0. Once the velocity becomes 0, it will start falling down in the reverse direction. Okay, this is how the velocity versus time graph is shown. So initially the velocity of the thrown object will be maximum, and as the time increases, velocity decreases. That is the reason, the object will be going to the maximum height and then starts falling down. So if the velocity is also increasing, it means it will go forever. So that is the situation we have to talk about. So as I said, initially that object has to have the highest velocity. So here, why we are representing here as a velocity, let's take, initially it has a velocity as a maximum, so I can write it as V max. This is the initial velocity with which the ball has been thrown vertically upward. As the time increases, the velocity decreases. Velocity decreases. For the certain time, the velocity becomes 0. It means that is the situation where the object is reached highest point and then starts falling down. Thereafter, it will start falling down. So for the falling down, I can represent the situation in two ways. One way, I can just continue in the reverse direction, showing that this is showing us the velocity, the velocity is increasing in the reverse direction. If I'm showing along, that is negative V. Or if I'm just interested on the magnitude of the velocity, so as that object increases, as the time increases, after we become a velocity 0, it will start increasing further. Means velocity when coming backward, when the object is coming backward, velocity starts increasing. So at this point, it caught again. So it means with what point you have thrown, the ball is at the same point. So while coming back, velocity increasing, while object is going up, the velocity decreases. So either the graph will be written in represented in this way, or the graph will be represented with this way. So we can see that from the options A, B, C, and D, we can see this option as represented as D. Many students get confused saying that A is the right answer, because A is showing that something is increasing then decreasing. But this is not the graph of velocity versus time. This is graph is representing position versus time. So position, or I can say the distance versus the time. As the time increases, distance goes higher, then again start decreasing. This is not the velocity versus time. Question is about velocity versus the time graph. So that's why D is the right answer. Okay, so this is what we're gonna choose here. So again, there is a confusion in the options. You can see that option A is representing D, B, A, C, D. We have to select these. We have to select any one among these, not this, because option A is representing that D, graph D represented as a D is the correct answer. So D is which one? So this part. So graph represented as a choice D is the correct answer, and that corresponds to the option A, which you have to select. Okay, this is the answer to the and this is how sometimes they get students get confused which A, B, C, D should I choose. So this is the way. So you have to look at on the options, not on the graph name. Let's move to the next question. Question number 7. Okay, so question number 7 says, in which of the four situations are the forces on the object not balanced? Question is about the forces on the object, on which situation it has not balanced. If you look at to the option, like the situations A, B, C, and D. So just check it out. We know that when this is the free body diagram which has been represented for certain situation, and in this we can see that like whichever the forces are in the same direction, we just add them as a to get as a resultant force. So if you look at to the option A, this is going to be 13 Newton acting on the left side, 11 plus 2. So 11 plus 2, again 13 Newton will be acting together on the right side. So this is balanced. Look at to the up and down, 7 plus 3, 10 Newton upward, and the 10 Newton downward. So this force is balanced. Okay, so then this can't be our answer, because we have to choose something which is not balanced. Okay, so look at to this part now. So 13 Newton on the left, but here they haven't given us the force directly. They have given us with the certain angle with the horizontal. So force has been applied with the certain angle with this horizontal line which has drawn. So we have to calculate the component of the forces, component of the force along the X, component of the force along the Y. So if I'm representing, this will be the component of the force along the y-axis, or we can say, because upward force, if I'm saying Fy, and this will be the component of the force along the x-axis, that is I am representing that as Fx, just as a reference. So it is creating a right angle triangle now by using the trigonometric concept. So let me tell you, we can use the SOHCAHTOA rule. So what is the SOHCAHTOA says? In a right angle triangle, this is the 90 degree if I'm representing, and if I'm talking about this as the angle opposite, it's gonna be the opposite side is named as opposite, and this side is gonna be the adjacent, and the side opposite to 90 degree always hypotenuse. And based on this, we have three major trigonometric identities. That is what we say SOHCAHTOA. So what is the So is basically sine of angle theta. It's gonna be opposite by hypotenuse. And what is the Ka? Ka is cosine of angle theta is equals to adjacent by hypotenuse. So far we just need only these two, so let me just use it as. So this is the angle representing, I am interested in calculating Fy. Fy is representing opposite and 15 Newton as a hypotenuse. So I can write it here as sine of 30 degree is equals to Fy by 15. So from this we calculate as Fy is equals to 15 sine 30, that gives us the 30 degree, that gives us the value as 7.5 Newton, because sine 30 is half. So this is balanced, And if you are looking for fx, so while calculating this, fx is acting as adjacent to the angle. So cosine of angle 30 is equals to what it is going to be, fx divided by 15. So from this I can say fx is equals to 15 cos 30 degrees. So 15 cos 30 degree, that gives us 12.994. I can round approximately 13 Newton again. So this is got balanced. So this side 13, this side 13. So because our calculator shows us the value 12.994, some other values. So it's approximately very much equal to 13, because we can't insert all the values. So we can just round it over here as a 13 Newton. This is also balanced. We are looking something which is not balanced, then I can't choose this as well. Now come up to this part, what it says, 40 Newton in this direction, 20 Newton this side, and 20 Newton down. So let's say to balance that, so force along the this has to be 20 Newton again, and the upward force also must be 20 Newton. So how do we gonna do that? So if you look here, so force has been applied with the certain angle called 60 with this block. But if you measuring this angle, how do we calculate the upward force or the normal force acting on this? If this angle is going to be 60 degree, then definitely this angle has to be 30 degree, isn't it? So this angle is 30 because normal means a perpendicular. So if this is 60, this angle has to 30 degree. Now let's calculate what is the Fy. So it means what will be the force exerting. So that is Fy. If it is getting balanced, then definitely D will be the answer. If it is not getting, then this will be the answer, because out of 4 options, any one is the correct choice. So this is acting as a right angle triangle. Now let's solve for Fy. Again, the same situation with reference to 30 degree. This is representing the adjacent. This is representing the adjacent, and this is going to be opposite. So let's calculate for Fy. I can directly write it here as Fy over Fy over 40, because 40 is the hypotenuse, is equal to cosine of 30 degree. So if you see that, so what will be the value of Fy now? Fy can be written here as 40 cos 30 degree. So what are you going to get the value here as 40 cos 30 degree? Just put it in the calculator. You'll be getting the value of 40 cos 30 degree here as something which gives us value here as 34.64 something. So 34.64 Newton. The downward force is 20 Newton, but upward is acting as a 34.64. So this is the one which is not balanced. So this is the answer. It means I have to choose the option which is representing C as the answer, C as the graph. Okay. So let's choose which option we're going to choose. Yeah. So A is representing. I have to choose the graph named with C. So this is the right answer to the question. So you just need to find the resultant force by using the basic rule of trigonometry, and that's it. So you're gonna get which forces are balancing or not. I can't waste my time for doing the D here again. Why? Because as I mentioned, out of 4, any one is correct, and once you get that as correct, so definitely that will be the choice. So here definitely it will be balanced if you apply the same rule for sine, cos, and all. Okay, so let's move to the next question. Question number 8. Question number 8 says a water piston has 2 sides. Side A, which has a square cross section of length 0.25 meter, and side B of a circular cross section of radius 0.5 meter. What is the mass M need to be added to the square across a cross section to lift the mass M, that is 1000 kg, on the circular cross section, knowing that the height is going to be 1 meter? It means if the question is referring to this diagram, they are trying to ask us what will be the mass M should I put on here, so that other side there is a mass M which is 1000 kg has been kept, and that will be lift with the certain height. So they haven't mentioned about how high it should go, that they are saying what mass should we put on this side, just so that the other side the piston can move up. Basically this is the concept of what? Pascal's law. And what is the Pascal's law says? according to the Pascal's law. So because basically this is the U shape, it's like, hydraulics. Now we can also say fluid mechanics part. So in the hydraulics, if you are applying a pressure on the one side in a U-shaped tube, if you are applying a pressure on one side, that pressure is equally distributed and equal amount of pressure will be exerted on the other side. So that is what the Pascal's theorem says. If I'm talking about a U-shaped tube, and if we are applying the certain pressure on the one end of it, so whatever the pressure we are applying, equal pressure will be distributed and it will be applied on the other side, because fluid is not compressible. So that's why pressure, how much you are applying, that same will be exerted on this side. So I can see now, if I assume P1 is the pressure applied at one end, P2 is the pressure at the other end, according to the Pascal's theorem, applied pressure P1 must be equal to P2. Okay, that's what we understand. Now what actually the further definition for P? So pressure, if I say the general definition, pressure can be written as force per area. Okay, this is the definition. Pressure is equals to force per area. Now what is the force exerting? As we are talking something more pressing, pressing down, pressing up, means we are applying the force with straight vertically down or vertically upward is exerted at the another end. We are talking about the applying the force on the vertical. And when we are talking about the force vertically, that's we talk about the, basically according to the Newton's law, force is going to be mass into acceleration. So in this case, force is going to be mass times the acceleration due to gravity. Why? Because we are talking about the gravitational acceleration, object is moving vertically. So this one we can modify according to the Pascal's law. This one we can modify now. This I can write it here as P1 can be written as F1 divided by A1 equal to F2 divided by A2. Now what is A1? A1 is the cross section area of this part, and they have said this is a square cross section with the length as 0.25 meter, and this is the circular cross section with the radius as 0.5 meter. Substitute, and from this one, how do we can further modify? Force F1 can be written as M into G divided by A1. Area is what? Area of a square is going to be 0.25 square equal to F2 can be written as M into G. M is the bigger mass whose value is going to be 1000 kg divided by area of a circle. It is, circular circular type of object here. So area of the circle here is going to be pi times 0.5 square. So let's solve for this. G and G will get cancelled out. We are interested in solving for the M. So from this, how do you do that? Simply just a cross multiplication. Take this area to the other side. It's finally a calculator part. Okay, so let me just write it over here. So M is equal to what we're gonna get. So M 1000, its value is going to be, capital M is 1000 times 0.25 square divided by pi times 0.5 square. And if you write this as it is in your calculator, you'll be getting the answer here as 79.57 Newton kg. So approximately we can round it here as 80 kg. So this will be the answer. But actually, if you look at to the answer keys, they have mentioned A as the answer. They have mentioned it as 17 kg. I'm not sure why they have mentioned it as a 17 kg. Probably it might be wrong, because this is how we calculate the mass. But if you get, like, in case if you solve and if you get an answer as 17 kg, please do let me know. According to me, this is what I can get. Okay, so I can round it there to the 18 kg, 80 kg. So I should go here with the option this 80 kg, but might be mistake. So in the option they have written as A as the choice, but according to me, I'm getting it as B. But if you get, please let me know in the comment box. All right, thank you. Okay, let's move to the next part. Question number 9. Question number 9 says a proton is accelerated to 90% of the speed of light in a particle accelerator. By what factor will the mass of the proton increase by? So this is basically a concept based on the Einstein's theory of relativity. They're talking about a proton is accelerated to 90% the speed of the light in a particle accelerator. By what fraction will the mass of the proton increase by? So what we can understand from here, this is like, the proton is accelerated with the 90% of the speed of the light. With this speed, what will be the mass of the, by what factor the mass of the proton will increase? So that is we're going to talk about. And according to the theory of relativity, how the masses are related, m is equals to m0 divided by square root of 1 minus v by c square. So this is what this equation can also be written as m is equals to 1 by square root of 1 minus v square by, or sorry, v by c square times m0. It means when the proton or any particle is going with the velocity as v, their mass will be increased by this much factor. This mass will be increased by this factor. By what factor they are asking us? By this factor it will be increasing. We just need to talk about how it is, what will be the speed here. And by knowing the speed of the proton, we can calculate by what factor the mass is increasing. So as they have mentioned, v can be written as 90% of the speed of the light. So I can write it as 90% of c, because c represents the speed of light, isn't it? So this is going to be speed of light, and its value is 3 into 10 to the power 8 meter per second. It's a constant, it will be given to us. This 90% we can also convert as 0.9 times the c, because while converting percentage into number, divided by 100. And if you substitute over here, what you're gonna get? So m is equals to, we are just interested in calculating the constant factor, okay? Square root of 1 minus 0.9 c divided by c square. So if you see that here, c and c get cancelled out, you just left with m is equals to 1 over square root of 1 minus 0.9 square. And if you put it in the calculator as it is, you'll be, this is times m naught is already there, and I'm just talking about the constant factor here, okay? So if you put this part as it is in your calculator, so you'll be getting this one as 2.29. So m is equals to 2.29 times the m0. This is by this much factor, the mass of the proton is getting increased, and that represents the option A. Okay, this is a formula based questions. I don't think so this formula will be given. This is from the modern physics. If you talk about the first part of the modern physics, as per the syllabus, is theory of relativity, relativity of length, time, speed. We can also talk about the mass and stuffs. Okay. All right, so let's move to the next question number 10. What question number 10 is talking about? The air pressure in a car tire is measured to be 35 psi when at a temperature of 28 degrees Celsius, and can be assumed to be an ideal gas. Though whatever they have filled, it's an ideal gas in a tire. Okay. The car is then driven for some time, and the internal air temperature then rises to 54 degrees Celsius. What will be the new tire pressure? Question is, calculate the final pressure in general. Initially, this was the pressure when the temperature was 28 degrees Celsius. Now, when the car is ran for some time and the internal temperature is going to be 54 degrees Celsius, now what will be the pressure? So let me tell you, this is again a formula based question. According to the, what is this, which concept it has related? According to the Gay-Lussac's law, I can say, or it can also, Gay-Lussac's law is also called it as the Hamilton's law. Hamilton's law. how the pressure and the temperature are related. So how they are just talking about how the pressure and the temperatures are related. According to them, at the constant volume, the relation says P1 by T1 equal to P2 by T2. What is the P1? P1 is representing initial pressure, T1 is initial temperature, P2 is final pressure, T2 is the final temperature. But consider temperature is in degree Kelvin. So here they have given us the temperature in terms of what? Degree Celsius. You have to convert into degree Kelvin. So if you substitute directly, definitely you're gonna get the wrong answer. So let's consider how do we convert the temperature into degree Kelvin. So temperature in degree Kelvin is simply temperature in degree Celsius plus 273. So whatever temperature in degree Celsius plus 273. So from this, let's calculate what is the value for T1 in degree Kelvin. T1 can be written as 28 plus 273. That gives us as 301 degree Kelvin. Same way, calculate for T2. T2 can be written here as 54 plus 273. That gives us 300 and what we gonna 27, 327 degree Kelvin. Now substitute. If you substitute that one, pressure one, I already know that. So this equation can be modified. So whatever the P1, T1, what we are writing here, this can be modified to solve for P2 as just do cross multiplication, bring this T2 to other side. Then your equation becomes P1 times T2 divided by T1 equals to P2. Substitute their values. Just substitute their values. P1 is going to be 35 times T2 is going to be 327 divided by 301. 301 that gives us P2. So if you put this one as it is in your calculator, you'll be ending up with the 38. And 38, the unit of pressure we are writing PSI here, it's gonna be P2. So the internal temperature inside the tire increased from 35 to 38. So this is what it shows. As the temperature increasing, pressure is also increasing at the constant volume. So this is how the temperature pressure relations. There are other formulas, are Charles law is there, Boyle's law is there. They just represent with the relation between the pressure, temperature and volume, considering one of the quantity to be a constant. Right, so let's go to the next question. Question number 11. Question number 11 says, the figure below shows a spherical wave that radiates from the source at S, where the black circle represents the peak of the waves. Now it says, assuming that I is the average intensity of the wave at the surface of the sphere of radius R, what is the average intensity of the wave at the surface of sphere radius 2R? Question is talking about what will be the intensity when the radius is going to be 2R. And this is the pattern which they have represented for the spherical wave that radiates from the source S. It could be a sound wave. Let's talk about a sound wave or any type of. But how do we measure the intensity? So let me tell you, this is a formula based question. Intensity of a spherical wave. Spherical waves means waves are generated in a sphere form and whose radius is varying. So that is intensity. Usually we represent with the formula as power by area. Power is the what amount of power delivered by the source, and because of that how much area it is covering up. So that is what the intensity is, power by area. Now what is area? We are talking about the surface area of a sphere. What is surface area of a sphere? Surface area of a sphere formula is 4 pi r square. This involves geometry also. So if I am representing here this one, this can be modified as I is equals to P divided by 4 pi r square. This is the actually how we can calculate. If you know the power and you know the what is the value of R, you can calculate the intensity. But question here is not talking about calculate the intensity. They are talking about what will be the average power, I mean like average intensity when the radius becomes twice, double, 2R. So this is the intensity formula. Now calculate the average intensity in the second case. Let me write it as for simplicity, average intensity when the radius is gonna be double. We can write it here as when let better like average intensity when the radius is going to be 2r. So that means let me just write it as, I'm just using as a reference just to note, like, I differentiate from the previous one. So the formula is going to be p divided by 4 pi times, I have to replace r with the 2r now, 2r squared. If you simplify it further, p divided by 4 pi times 2r square can be written as 4 and r square. Okay, so this is how this we can write it. If you further simplify it, this can be written as p divided by 4 in the bracket. I can write it as 4 pi r square. I just took, like, just modifying, I just took that 4 out here. So why I'm doing that all? Because I know that intensity p divided by 4 pi r square is this value. This is the I. So this can be further written as, I can write it here as this, everything is represented as a I. So I can write it as I divided by 4. So this is I divided by 4, I can say, or 1 by 4 times the I. So this is how the intensity is related. So average intensity will be I divided by 4. So compared to the initial intensity, it's got reduced by 1/4 of its value. As the radius increases, doubles, intensity decreases by this value. They are inversely proportional. Let's move to the next question. Question number 12. Question number 12 here, what it says, if the work function for silver is 4.70 electron volt, what is the minimum frequency of incident light that will cause a photo emission of electron? So this is basically talking on the concept called photoelectric effect. Now, what is the work function? Work function is basically the minimum amount of energy an incident light must have to eject the electron from the metal surface. Let's say, for example, if I say this is the metal surface on which are the certain electrons, light intensity, light energy which is falling on this, if this light has a certain amount of energy, then only the electrons are represented. For example, electron removed from here is going to be with the energy, let's say 20 electron joule, for example, and intensity light which is falling is going to be, let's say 15 electron joules, for example. So because the falling light intensity lesser than the what they required, in this case photoelectric effect will not occur. So if the applied light is greater than the 20 only, that will be removed, and the minimum amount of energy required is going to be the work function. Okay, and that is usually represented with the notation as phi, or we can also say psi. All right, okay. So how, again, this is a formula based function, how the work function and the frequency are related. Let me tell you, the work function will be formula here, I can write it here as initial or the minimum amount of energy or work function, we can write it as h times f0. F0 is representing the minimum frequency of the light. So minimum frequency of the incident light which must have. If there is light has the lesser than that, it will not be ejected. So question is about to solve for the f0. So f0 can be written as 5 divided by h. Now what h is representing here? H is called Planck's constant. Planck's constant, and it's a constant value, and it will be given to us as the work function as given to us in electron volt. The Planck's constant value in electron volt is going to be 4.14 electron into, like, 4.14 into 10 to the power negative 5 into 10 to the power minus 15 electron volt second. So this is the value of h, 4.14 into 10 to the power minus 15 electron volt second. There is another value for h when the energy is done in terms of joule. Both will be given to us in a formula. So you have to just refer which is the relevant, whether in terms of electron volt or in terms of joule, accordingly we'll be using. So here we have to use this. So let's calculate here. F0 equal to 4.70 electron volt divided by 4.14 into 10 to the power negative 15 electron volt second. So just put it in the calculator, you'll be getting it as 1.13 into 10 to the power 15 hertz, because per second we can say it as a hertz. So that's why we go with the A as an option. This is how we solve. Okay, this is the answer to the question which is asking for the minimum frequency. Question number 13. Again, it's from the electricity and magnetism. Which diagram represents the electric field between the two oppositely charged conducting spheres? Oppositely charged conducting sphere. They are talking about the spheres. One is positively charged and one is negatively charged. So let me tell you, for the positively charged, when the charge is positive, let me tell you, if let's say consider this is a positive charge, and for the positive charges, electric field will be ejected away from it. It means it will be going away from the positive charge. This is the way of representing the electric field. This is always okay. And when the charge is negative, the electric field will be coming towards it. Electric field will be coming towards it when the charge is going to be negative, away from it when the charge is going to be positive. And when these two spheres or the two charges are being near to each other, electric field will be going away from the positively charged and emerging at the negative charge. We can see that going away from this, emerging here, going away from this, emerging here. And this kind of situation in electric, this is called electric dipole. Electric dipole. So this is the situation. So which is representing the same type? I can say A is the answer. B exactly talking about, because they are saying whether it is positive or negative electric field is away, it's wrong. C talking the same situation in opposite direction again. So whether it is positive or negative, they are saying pointing towards. D is going to be positive towards, negative away. So this is wrong. So only option left here with the positive and negative charges, option A. All right, so let's move to the next question. Question number 14. So let me just see. This was 13 we did. Yeah. Let's go with question number 14. Question number 14 is just a theoretical question. So there is not much required. They are saying a car travels with a constant, look at here, constant non-zero acceleration along a straight line. When the object is moving on a straight line and acceleration is not zero, then definitely there is an increase in the velocity of that object. So why? Because acceleration itself says the definition of acceleration is changing the velocity by time. So if velocity is changing, it means final velocity, initial velocity. If there is a change in the velocity, then only acceleration becomes non-zero. Whether it is increasing or decreasing, but acceleration becomes non-zero. So we have to predict up which graph is representing this situation. When I'm saying the velocity is increasing, it means the speed is increasing. Speed is increasing as the time increases, it's covering up the more distance. So which one is representing? That represents the option A. Because initially, when the time was zero, distance was zero, as you slowly go, you are speeding it up. Speeding up, you are covering the more distance in the same amount of time. So that is like, in 1 to 2 seconds, 3 seconds and all. So that is representing option A. B is wrong because it's saying that when the time was zero, we have already at the certain distance, they are saying. C is also wrong because just talking of the situation, C is like a something thrown up, goes, comes down. It's basically the parabola or trajectory motion they are talking. D is also speed, distance, time, what I can represent, but with the constant speed. This is with the constant speed. If the speed or velocity is constant, then in this case, acceleration is going to be zero, but condition says acceleration is non-zero. So that's why we won't go with this option as well. And the left one is the option A. Okay, let's move to the next. Question number 15. The diagram below shows the two pulses approaching each other in a uniform medium. Which diagram best represents the superposition of two pulses? Let me tell you, superposition, basically the addition. Addition, or I can also say subtraction as well. It depends on how the pulses are overlapping. If two pulses, for example, this is one pulse having a certain amplitude, and this is also another pulse having certain amplitude. If they are coming in this way, we add their amplitude. But another, this is what we say, we add them. And another one, one pulse is like this and another pulse is in the opposite way, another pulse is something like this, in this case we subtract. Okay, so they are we subtract it. So this is what the superposition. Subtracting means we just subtract one amplitude with another. They are saying shows that the two pulses approaching each other in a uniform medium. I mean, this pulse is approaching like this pulse is going in this way. It means after some time that definitely they will come, the situation will be here, one pulse, bigger one will be like this, and the smaller pulse, whichever we are representing with the 5 centimeter, it will be like this. They will be overlapping in this way, peak to peak. And as I said, when they overlap, they must be added. This is gonna be 5 centimeter, and this is gonna be 10 centimeter. The together they will produce a very big amplitude pulse, which has a 15 centimeter in total. This is what? So 5 plus 10, 15 centimeter will be the amplitude of the new resulting pulses, and this is called a superposition. So which one is representing that one? You can see option A. Without checking with others, we can go directly A as the option because all they are getting added up. Question number 16, it's completely a theoretical. One vibrating 256 hertz tuning fork transfers energy to another 256 hertz tuning fork, causing the second tuning fork to vibrate. So what type of phenomenon is this? So when we are talking about the tuning fork, what type of tuning fork? It's something like this, something. So like if you hit somewhere on this one with the some rod, this will be vibrating like this, and vibration will be generating a energy. If you keep the there is another tuning fork of the same type which has been kept at the certain nearby, whatever the energy produced by disturbances this side, that energy, let's take the energy produces by this is going to be this way, it will be interacting and it will make to vibrate the same another one. And this phenomenon, it is called a resonance. The resonance is like, vibrating the tuning fork just by vibration. Another one also we call it as a resonance. It's even though if you don't know the definition, you can just see that diffraction, it's basically the spreading of the light or waves. Refraction, it's basically entering from the one medium to another. Reflection is bouncing back into the same medium. They are not at all talking about the situation what they are mentioned. So A is the best choice here. Probably this will be the last question. Let's see. Question says, which circuit has the largest equivalent resistance? It's basically from the electricity and magnetism. So let me tell you, there are two combinations of resistance we can keep. One is called the series. When the resistors are connected, like a peak to, like, one terminal of this is connected to another. For example, this is R1, R2. In this case, the total resistance, we write it as Rs, is simply adding individually R1 plus R2. But when the resistors are connected in parallel, what is the parallel? All the terminals of the resistors are connected with one common point, and this is what we can say. Now these are the parallel combinations. So if I say this is R1 and R2, what will be the net resistance produced in the parallel? 1 divided by Rp. We write it, this is the formula, it will be given. Okay, 1 divided by Rp is equals to 1 by R1 plus 1 by R2, like this. So now let's use it as which one will give us the largest equivalent resistance. Let's go with the options. A, all the resistors are connected end to end, so mean they are connected in the series along with a certain battery. Like they are not asking about the what amount of current is going, just only equivalent resistance. In this case, Rs, we can write it here. I just add them. 2 plus 2 plus 6, that's gonna be 10 ohm. And this is the 10 ohm. So far we got it as B. It's gonna be what? They are connected in parallel. So 1 by Rp can be written as 1 by 2 plus 1 by 2 plus 1 by 4. 1 by 2, 1 by 2 plus 1 by 4. What value? You just put it in the calculator, but definitely you're gonna get a very small value as compared to the 10 here. So this is gonna give us in this situation as This, if you put it in the calculator, you'll be getting 1 by Rp equal to 4 by 5, or Rp equal to 5 by 4. I can just reciprocate it. So 5 by 4 basically 1.2. So here Rp is giving just a value as 1.25 something. So next, option C. C says again they are connected in a series, end to end. Then the total resistance here is we just gonna add 2 plus 2 plus 4, that gives us 8 ohm. And option D is in terms of what? Parallel. Definitely what we saw is parallel combination gives us the very smaller value of resistance. So if you just looking here, 1 by Rp equal to 1 by 2 plus 1 by 2 plus 1 by 6, that gives us the value here as 1 by Rp equal to 7 by 6. So from this one, Rp can be written as 6 by 7. 6 by 7 even lesser than 1. So the which one is producing the greatest? 10 ohm is the greater equivalent resistor. We should go with option A.